CSEC Mathematics May 2025, question 3. Alright. It says here, using a ruler, a pencil, and a pair of compasses, construct the triangle PQR such that PQ is 9 centimeter, angle QPR is 60 degrees, and PR is 12 centimeters. That's part A. Let me copy it and paste it over here. Alright. Now, we have here this construction to be done. Now, you get your ruler. I think I have a ruler here. See if I can find a ruler. No protractor, you know. Only the pencil, ruler, and compass you must use and do the construction. Now, PQ is 9. Let me see if I can draw PQ here. PQ is 9 from here to here. Alright, that is 9 centimeter. Alright, PQ. Now, angle QPR is 60. Okay, so R will be somewhere up here, wherever it is. So, this is something here. You take your compass, put the compass point here, open. By the way, I don't want to do that. Let me use thinner line for construction line. Alright, so swing an arc there. Alright. Put the compass point, intersection of the arc, and here, and swing another arc. Now, let's see what that line will be about. That line here. Let me draw it from here. Whatever that line's length is. R will be somewhere there. It says PR is 12. Okay, good. So if PR is 12, this is kind of close. Let me get it out of the way. I need to extend PR some more. 12. So that is R right up there. Alright? PR is 12. And then of course you're going to join Q and R. Let me draw this line. Alright, good. So there we go. There we are. Now remember, you see this part? Notice this angle is at 60 degrees. Because if you should draw a line here, well, not a proper line. If you should draw a line here, remember, from here to here, you open the compass, and then from here to here is the same distance. So if this, it means that this line, and this line of this little triangle here, they are all equal. So this must be 60, this must be 60, this must be 60. You see that? So it's really a little equilateral triangle you have right down the corner there. Right? So that's a 60-degree angle. Let me kind of fix up the top here. Good. So that they meet. My kind of mess it up, you know. Alright, anyway, you get the idea. But the thing is now, that's PQR. What else I say? Oh, that's that for the construction, right? So you must make sure you show the construction lines and label the triangle, alright? That's part A. What part B so now? The diagram below shows two quadrilaterals, R and S, alright? Remember, quadrilateral means figure with 4 sides, alright? It is a polygon with 4 sides. S is the image of R under transformation. S is the image of R, alright? What they say you must do. Describe fully the single transformation that's mapped quadrilateral R onto quadrilateral S. R to S. That's 3 marks. Now the thing is, from looking at it, you can see that it is an enlargement. They are similar, alright? Same orientation, same angles, but the length of the sides are different. So you must find out what is the scale factor and the center. So what you can say here, it is an enlargement of scale factor, whatever it is, and center. Alright, so you must find out what is the scale factor and the center. Looking at this, notice here that an R from here to here is 1, 2, 3. But from here to here is 1, 2, 3, 4, 5, 6 centimeters. 6 divided by 3 is 2. And same thing here. This height is 1 and this height is 2. Again, 2. This height is 1, 2, 3 and this height is 1, 2, 3, 4, 5, 6. So it doubles. The length of the side doubles. So scale factor 2. And the center now, you need to identify the center. Where is the center of the thing there, the enlargement? If you do it graphically, what you will do here is use your ruler, right, and line up this and this. Line up this line somewhere here, join corresponding lines or corresponding sides and see where they meet. This is kind of awkward the way I'm doing it, but you get the idea, right? But a more accurate way is to use a thing there, formula, right? Now, there's a certain formula that says x2 is equal to the scale factor times x1 minus x, call it C for the center, plus x center. So what happened here? And by the way, let me just copy this part of the graph and paste it over here instead of switching back and forth between the diagrams. Alright, so we have our graph here. But here, x2, the second object, or you can say the image. The original one is the object. The image here. If you put the image, the x for the image x2 over x1, you get the scale factor, right? The scale factor. Just like what we did, the length of the image over the length of the object. Now, here, what we have is if we multiply both sides by x1, we get x2 is equal to scale factor times x1. Now, if we move x1, the point and the object, to the center of enlargement, multiply it by the scale factor, right? And at the center of enlargement, we get x2. This is x2, this is x1, right? So x2, we pass it through to the center of enlargement, multiply by the scale factor, and then add it back to the center. Then what we get is this formula here. Now it's good to remember the formula, and I don't know if they would ask you to calculate it. They did not ask you to calculate it, so you could show it using thing there, using drawing. You could do it with this formula. Now, same thing applies to y. y2 is equal to the scale factor times y1 minus y at the center plus the y at the center of enlargement. Now, what we could do is this. We see here that x2 at this point right here, our x2 is 5. So we say 5 equal, the scale factor is 2 times x1. Now, this and this on the object and this on the image, they correspond, right? Right at the corner here. Our x1 is 4, all right? Our x1 is 4 minus x at the center of enlargement, whatever it is, right? Plus the x at the center of enlargement. Now, if we multiply and so on, 5 equal 2 4s 8 minus 2xc plus xc. So 5 minus 8 is equal to negative 2xc plus xc, which is negative 1xc. 5 minus 8 is what? Negative 3. Negative 3 is negative x for the center. So the x for the center of enlargement is 3. Alright. What about the y now? For the y, for that point, y is 1. So we say y2 on the image, what you get after the enlargement, y2 is 1, equal the scale factor is 2 times y1, the original location was 4, y1 is 4, minus y at the center plus y at the center. Alright, So 1 is equal to 2 fours 8 minus 2 yc plus yc. 1 minus 8 is negative. Or let's just say 1 minus 8 equal negative 2 yc plus yc. 1 minus 8 is negative 7 is equal to negative 2 plus y at the center is negative y at the center. So y at the center is 7. So xc comma yc. The coordinate of the center of enlargement would be, it looks like it will be 3, 7. Now we could do it with other points too. Well, let's see. Let's take a look at this if you think it would add up. If you should draw a line through these 2 points, would they meet at 3, 7? Let's see. Let me try and draw a straight line. Straight as I can. That one is lean. Let me try again. Trying to aim for this point. Well, if you kind of lean it, because I want it to go through 3, 7. It's approximate. My, what's happened to my line? So let us do it again for this one. These 2 points. Oh, what happened to me? You know what? I'm going to copy this entire thing and put it over the other screen, because that would work much smoother and would have less problem. Alright, where did it go? Right here. Alright, so let's see what happens in this case. So if we draw a straight line between these points, and a straight line between these points, right, you can see it. Is actually 3, 7, you know. Above 3 and besides 7. 3, 7. Right. It's 3, 7. But anyway, let's see what else is going on here. Oh, part 2 and 3. Let's say on the grid on page 12, draw the image of quadrilateral R when it's translated by the vector negative 4, 5, name it t. The vector is negative 4, 5, I name it t. Alright, it's the same thing this, so let's erase what we have here. So what they say, translated by R, the image of R translated by negative 4, 5. Image of R translated by negative 4, 5. Now remember, when it's a negative 4, 5, that means generally it's x, y. X, the top number, it moves to the right if it is positive, or to the left if it is negative. Y, the bottom number there in the column matrix there, it moves up when the number is positive and down when the number is negative. Now the negative 4 means that each point must be moved 1, 2, 3, 4 to the left. So this will end up here. This is 1, 2, 3, 4 to the left. This point is here. Right? 1, 2, 3, 4 to the left. This point will end up here. And 1, 2, 3, 4 to the left. Alright, so the outline of what you would have here so far, the outline of it would be this. Alright, so that's the horizontal movement, the x. Now the y movement means here y is 5, so each point will move 5 places up. So here this point move 1, 2, 3. I need more space here. This point moves 1, 2, 3, 4, 5 places up. I had cut off the thing there, the part of the graph. I should be up here, but you get the idea. This point moves 1, 2, 3, 4, 5 places up, so it ends up here. This point moves 1, 2, 3, 4, 5 places up, it will be beside 7. And this moves 1, 2, 3, 4, 5 places up, it's beside 6. So, what would happen here is that the new quadrilateral would be this. So what they say? Name it T. Alright. So you call this T. Alright? What happened after that? On the grid on page 12, draw the image of quadrilateral R when it's rotated 180 degrees about the origin. Name it M. Okay. So now you rotate it. You rotate R 180 degrees about the origin. Alright. Let's use another graph and not crowd this one too much. Where am I going to put it now? Where should we put it? Let's get rid of this one. This one was there from before. We used it already. Alright. So now, what they say? Quadrilateral R is rotated 180 degrees about the origin. Now, here, this R rotated 180 degrees about the origin. You know, we're going to need the full thing there now. We're going to need more of the graph paper. So, let us do it like this. Let's copy this and paste it over here. Then drag this down. Alright. Now, we're going to rotate it 180 degrees about the origin. You can do this by drawing. You could say, if you swing this 180 degrees about the origin, right? You swing it right around this. This point would come here. Because really, you know, what happened is like you have this line and then, or let's get back the ruler to illustrate what I'm saying here. Or get another ruler. If you consider it like this, this is the origin. This is your point right here, alright? If you should take the ruler and swing it 180 degrees around, right? The point that was here would swing right back around and come here, right? So that's that. Now that point would end up here. And you could continue doing it for the other points, right? But the thing is, you can calculate what the new points will be. And that's what we're going to do, all right? Now, let's see if we can get a matrix that will result in a 180 degree rotation about the origin. Now let's say that matrix is in the form A, B, C, D. And remember, no, we're taking long and we're explaining because we're not in exam today. When you go in exam, it's going to be a different story, but this is for detailed explanation and so on and so forth. If you multiply A, B, C, D by X, Y, what are you going to get? Now, 180 degree about the origin. If you should do it with this, it would come down here. So, when X was 1, X would be negative 1. And you see when Y was 1 before, up here, Y is now negative 1. So basically, you will get negative X and negative Y. It would happen for all points. If you do it by drawing and you rotate them 180 degree about the origin, this is what would happen. So in this case, A times X and B times Y. So if you should multiply these matrices, you would get AX plus BY. You have to remember your multiplication of matrices, you know. This would be CX plus DY. Now, there's no Y at the top here, so you can see that B equals 0. A would be negative 1. What about C and D? There's no X at the bottom here, so you can see that C is 0. What about the Y? Y changed from positive to negative, so D is 1. So the matrix you're looking at is negative 1, 0, A, B, C, 0, D. Oh, it's D would be negative 1. Negative 1. So that's the matrix. So if you take this matrix and multiply by any point here, you're going to get what results from rotating it 180 degree about the origin. So you say negative 1, 0, 0, negative 1, multiply by, in this case, 1, 1. This point here, we're going to rotate it. Negative 1 by 1 is negative 1. 0 times 1 is 0. 0 times 1 is 0. Plus negative 1 by 1 is negative 1. So you get negative 1, negative 1. So this is one of the points that we're looking at. Alright? This point here is 1, 2. So you work it with 1, 2. So you have negative 1, 0, 0, negative 1. When you multiply these matrices, you're going to get negative 1 times 1 is negative 1 plus 0 times 2 is 0. Negative 1 times 0 is 0 plus negative 1 times 2 is negative 2. Alright? When you multiply the matrices, you have to remember your multiplication of matrices. Negative 1 plus 0 is negative 1. 0 plus negative 2 is negative 2. So negative 1, negative 2 is what you get. So it's going to be negative 1, negative 2. Going to end up negative 1, negative 2 right here. So this point, right, it would swing around to here. We have the other point here already. The point 4, 1. If you take 4, 1 and you multiply negative 1, 0, 0, negative 1, you can try it, right? You're going to get negative 4, negative 1. Alright? So this will be negative 4, negative 1 right here. And then this point is 4, 4. It will end up at negative 4, negative 4 right here. So when you rejoin all the points. Let me redo that part. When you put all the points back together, that is what you get. Alright? What do you say you must label it as again? Where is it? Oh, it's down here. Name it M. So this is M, the image. Alright, so that is it for question 2. I will see you for question 3 in our next video.